Alright, so once again, welcome everyone to RockEDU Presents. Again, I'm so excited to have everyone here. And just as a brief intro, just want to let you guys know like what we're about. So I know I've seen some familiar faces. Who is here for the first time? Nice. So we have a few first-timers, which is great because, I mean, we have regulars. And so our RockEDU team, we're RockEDU Science Outreach at Rockefeller University. We work at the intersection of basic science research and the STEM to collaborate with our community of scientists at Rockefeller University, professionals in STEM, to work with the K-12 community in New York City. So we're really trying hard to provide access and just share how amazing science is in general, because I think it's super cool and I think you should think it's super cool. And so today we're having our RockEDU Presents. We have our RockEDU Presents every third Friday of the month. Today we have a civil engineer from New York City. Next month, April 20th, we actually have, I think she's a psychiatrist, Dr. Katie Davis. And just pull up my phone so I can tell you what she's going to do. So she's actually going to talk about the connection between learning disorders and anxiety, and how she's going to discuss basic strategies that's going to reduce school-related anxiety and improve your studying. So if you feel like you have a difficult time studying and you have anxiety, yeah, I did too, I still do, right? So if you're even remotely interested in that, please check us out on next RockEDU Presents. That's on April 20th. We have Dr. Katie Davis coming in. And so today we have our New York City civil engineer, and just a little bit about her, and then I'll have her just introduce herself a little more. So she's Madeline Skoblik, also known as Maddie. So she joined the New York City Department of Design and Construction early in 2016. She studied civil engineering at the University of Wisconsin-Madison and graduated in 2015. Not only is she a civil engineer, but she does enjoy doing other things, such as playing softball. She runs, so she's pretty athletic. She can probably outrun me, because I can't run enough. And she also plays an instrument. So she was in a marching band in school, and she plays the trumpet, and she enjoys music of all sorts. So today she'll talk about her experience in the NYC DDC and how they work on the infrastructure projects throughout all 5 boroughs of New York City. So if anyone here, basically New Yorkers, and you've been wondering how in the world they get everything to work together so streamlined, you came to the right place. All right, so join me as I introduce Madeline Skoblik.
Hi everyone, how's everyone doing? Good. Thank you all for coming. My name is Madeline Skoblik. I'm a resident engineer for the New York City Department of Design and Construction. So I do project management on capital infrastructure construction projects throughout mostly Manhattan, but also all of the other boroughs in the city. So a little bit of my background. I'm originally from Minnesota, from right outside of Minneapolis. I went to college at the University of Wisconsin-Madison. I graduated in 2015. I moved to New York shortly after in early 2016. So I've only been here for a few years, but I think I've learned a lot in that amount of time. So my topic today is why New York City works, a lesson in civil engineering. So I'm going to be looking at all of the kind of unseen infrastructure that allows the city to function on a day-to-day basis and allows 8.5 million people to exist and live, work, and recreate on a day-to-day basis. Raise your hand if you've heard of civil engineering before. I think we got like a little bit of us. So I'm going to kind of go into the history behind what civil engineering is and the history of that. So civil engineering is the oldest engineering discipline. It's been around since the first human beings walked the earth, since they first put up their stable structure or maybe pushed a log over a river, kind of any man-made object that allows us to exist within the physical and built environment. Civil engineering is a discipline that deals with the design, construction, and maintenance of the physically and naturally built environment. And by built environment, I mean all of this. So pretty much your buildings, your roads, your sidewalks, curbs, bridges, all of your underground utilities, the paths through the parks that we have, the subway stations. So you can basically call New York City like one giant built environment. I'm going to go through some of the different types of civil engineering right now. So there's different subtypes. These are just some of them. But we've got structural engineering, which deals with buildings, bridges, tunnels, anything where you're looking at how am I going to support the weight in this structure and make sure that it doesn't fall down. Then you've got transportation engineering. So they kind of deal with the flow of vehicles and people. So that's like the signal controls within like the subway system, or you have the traffic signal timing in the city to allow the traffic to flow well. That's all transportation. We have engineering, construction, and management, which is kind of what I do. So this is taking the designs that people make and practically implementing that outside. So I work directly with construction workers. I don't do the construction work. I just oversee what they're doing. So that's kind of the management side of it. Then you've got geotechnical engineering, which is like your foundations. So what soil do we have underneath what we're building? It's important because, like, you know, you could have something that the soil isn't good, or it has too much water infiltration, and you're putting a building on top of it and it sinks into the ground, kind of like the Leaning Tower of Pisa. That's kind of what happened with that. So geotechnical is all the materials below that provide a good solid foundation for your buildings or the different structures that you're putting up. And then you've got water resources, which is where's our water coming from? Where is the water that we're getting to cook or clean ourselves or different things like that? And then what are we putting out back into the environment? The wastewater, how we're treating that, and how that's going to be environmentally friendly. So these are all some different types of subtypes of civil engineering, but these are all involved in infrastructure work within the city. So if you know how, like, when you're sick, you'll go to a doctor to get a diagnosis and a cure. I would consider the civil engineers to be the doctors of infrastructure. So if there's any issue with a building or a bridge or something's not functioning quite right, we go in, we diagnose what the issue is, and then we will provide a cure for that. So I'm going to go into kind of the history of how the city was formed. So the first settlers, the Dutch settlers, came to the island of Manhattan in 1609. They chose this location specifically for its proximity to the East River and then mostly the Hudson River, because that went all the way north into the mainland, and it connected to valuable trading assets. And it could also be used as a military outpost to protect the mainland from any invaders. So they came to this kind of marshy, rocky, hilly land. The original Lenape Indian word was Island of Many Hills. So obviously that changed a little bit from what it was to what it is today in just over 400 years. So I'm kind of looking at how it went from this to this and all the systems that were in place to change that. One of the largest changes, the most drastic, were actually the expanding borders of Lower Manhattan. So this is the first known map that we have of the city. They've got this fortified wall, which is where Wall Street was named after that. So that's Wall Street, and then this is like a military outpost. It was actually a fur trading post. And then anything north of this is pretty much unoccupied land in the 1600s. So once the population started growing, you had people, they initially just went north on the island, but then they wanted to expand a little bit outward, so they built what was called reclaimed land. So all of this is the current, I guess to 1980, but it pretty much looks like that now. So they expanded out by 1,000 feet on either side. Reclaimed land is basically where you put a bunch of pretty much trash, it's like landfill, into the water, and then you put dirt on top of that, and then you build on it. So that was what this was. Sometimes they would actually sink entire ships and use that as a foundation for buildings and stuff. I'm sure we could find more of them, but they found one when they were rebuilding the World Trade Center in 2010. They dug down far enough, so they found the hull of this ship, and they traced it back to 1773. Apparently it was made out of Philadelphia. So that was like one of the most recent finds. Anyways, so they used to do that. And a lot of the land in Lower Manhattan, not really Upper Manhattan, but down here is reclaimed. Like Ellis Island, Rikers Island, pretty much all of FDR Drive. We're pretty close to that right now. And Battery Park City, that they actually built from all of the dirt that they excavated out from the World Trade Center site. So they just excavated it and like moved it down and then built Battery Park City. So this is one of the most drastic changes. I thought this was pretty interesting. So like the outline of Manhattan Island as it was in 1609 is this red line, and then when Hurricane Sandy came through, this is the storm surge area. So you can kind of see how it like goes pretty much up until that original outline of the island of Manhattan. So I'm thinking if we hadn't reclaimed all of this land, would it have flooded as bad as it did? I mean, you can't really know, but it's interesting to think about something like that. There's also this plan in the early 1900s. They wanted to infill the East River, and I'm like, I don't know how this would be done. It takes a lot of dirt to fill that in. But they were trying to like fill this in and then make a new East River through cities in Brooklyn. I'm like, I don't want to mess with the original land, because like if there's water flowing in one direction, it usually will come back and try to flood that area again, as you can see from the last slide. So maybe it's good that we didn't do that. And also at this point, they were expanding a lot in manufacturing jobs, which means that they needed a lot more land space. They weren't building up, but they were building out. But then once manufacturing started going down in the early 1900s, they actually started building upward, because people could just work in office buildings and generate money through that. So they didn't need the extra land, and so that's kind of why they scrapped this plan. Did you know that we use 1 billion gallons of water a day in the city of New York? So this is Central Park Reservoir, but basically water is essential to the functioning of the city. If you don't have water, you have no city, because people can live without electricity, they can live without the other luxuries, but they can't live without water. So I'm kind of going through all of the processes that were put in place to allow us to have stable, clean, reliant drinking water right now. So the original water sourcing on the island, they were all finite sources of water, like the water table, below ground. They would use small streams, ponds, stuff like that. They had this thing called the collect pond, which is kind of in like Chinatown and like the 5 Points area. That's where this was. And so that's where a lot of people got their water at that point. Obviously they can't get it from the ocean because it's salt water. Here's another picture that I found. This is the collect pond, and this is a little rocky, hilly outcropping there. It provided the first 2 centuries of water in Manhattan. But as more and more people came to the island and they started living, and the human, animal, and industrial runoff basically leaked into the water, and it became really polluted. So over time, they had to find new sources for this. One of the catalysts for this was actually the prevalence of fires in the 1800s. They wanted to develop a waterworks system, which is kind of like a comprehensive, reliable, clean drinking distribution system. So they had a lot of fires happening because the population grew. You had a lot more buildings, like wooden buildings close together, and the firefighters couldn't get the water to where they needed it to be. They would, because they didn't have like a hydrant system or anything like that. I feel like we take that for granted, but they didn't have a system underground providing them with water, so they'd have to like use bucket lines like over here, stuff like that. So to prevent any further large fires, they wanted to set up this waterworks system. So they actually set up a system of wooden water mains. The interesting thing about this is that, they ended up using, I think they had a law passed where they could source the water from the Bronx River, but whoever was running this wasn't very good, and they ended up still sourcing it from lower Manhattan, from the groundwater table, from the little wells that they already had down there. They put a reservoir in current day Tribeca, and they were using like a horse-powered and later steam-powered engine to pump this up. And then they had a system of wooden water mains, which are like logs that they bore through with an auger that kind of just removes the interior and makes like a cylindrical hole in the log, and then they taper one end to the other and they can fit them together. So it would pump the water into this system, and then it would just flow by gravity down into to the different parts of the city. Obviously, most of the people that had like their own house connections were very wealthy people at this time. The poorer people had to continue relying on the groundwater wells and stuff like that. And there were some other flaws with this. So like the wooden water mains, this is one being removed from a trench. You can still find them once in a while in lower Manhattan. I think this is the South Street Seaport, but one of the downsides to this was the fact that they were they were susceptible to tree root infiltration, so like trees would grow above them and then the roots would go into the logs, but they would freeze in the winter. And it just wasn't a reliable source because they were still using the finite water sources from the collect pond and different areas like that. So they had to find another source. They ended up, here's some logs on display at the DDC headquarters. This is, my place of employment. So we have a few logs here. We do a lot of water work within the city because it's a public service, and that's kind of the work that we do. Anything that the public would use. So this is an example of some that we found recently. They ended up building this aqueduct system in the mid-1800s called the Croton Aqueduct, where they dammed a lake up here, like Westchester County, and then they built a series of bridges or aqueducts and tunnels. So an aqueduct is like a large arched bridge where they can allow water to flow, gravity flow down. And then they had some tunnels over here. The High Bridge was actually one of the DDC projects when we did the restoration of that recently. And it flowed all the way down into this receiving reservoir, which is actually where the Great Lawn is now in Central Park. And then it went down to this Croton distributing reservoir, which this is where, I think they designed it after like ancient Egyptian architecture, kind of looks like that. And this is where the New York Public Library is now, and Bryant Park, so it's kind of interesting. And then it would flow out from there, but this drastically changed how people could live, how the quality of people's lives at that time, because they were able to have consistent clean water sources. They had bathhouses open to the public. Disease was going down because things weren't, they didn't have to use the polluted water anymore, stuff like that. So it was really beneficial to the city. One of the other downsides of this, though, is that people weren't drawing as much water from the water table below, so it started rising again. And then you had people's basements and cellars starting to flood. They ended up having to install a sewer system to get the water out, away from those. And I will talk about that in a little bit. But this is the first aqueduct system they set up. They rebuilt a newer, larger one in 1890, I believe. And then this is the current New York City water supply system. So this is the Croton watershed. That's kind of what I was talking about before. And then they've expanded all the way up here to the Catskill, Delaware watersheds. So the New York City water system is considered kind of the gold standard of urban water supply systems in the world. So we have some of the best water and the largest system ever made. Here's the High Bridge restoration of DDC. That was, where was that, over here? No, it's, yeah, right there. Anyway, so the water comes from, they put in a few more aqueducts over here. It comes all the way down. Again, this is all gravity flow. And it goes to what's called the Catskill UV plant, named after the Catskill, Delaware watersheds. Here, because the water is unfiltered coming into this, they have to make sure they're getting all the contaminants out. They used to put like a lot of chlorine into the water. They found out that, and that will disinfect it, but it's also not great for people to ingest that much chlorine. So they found this technology in the late 90s called, where you could basically treat different toxins with UV light into the water. So like cryptosporidium was one of them that they were trying to deal with. Basically you treat it with UV light and that'll get rid of that, so they can put less chlorine into this water. It actually saved them a lot of money doing this versus building a giant wastewater treatment plant. So they put a lot of money into this, but it has saved a lot over time. After it goes to the Catskill UV plant, we're going to go down into these water tunnels. We've got 3 of them now. The first 2 were built in the early 1900s, and the third one was just opened in 2013. It had been under construction since the 1970s. That's a very long time. And these are built, they're huge tunnels, as you can see. They're built really deep in the ground, probably like 800 feet down. And it's all gravity flow. So it comes out of the Catskill UV plant, it goes into these tunnels, and the pressure of the water is so large that they have these shafts going up to the surface that it'll just shoot up these shafts, and then it'll go into this trunk water main system, which is like, they're probably 3 to 5 feet in diameter, larger pipes going throughout the city. And then you go into a distribution water main system. So that would be stuff that we replace on a regular basis, like 1-foot ductile iron pipes. And those are going down every single street in the city. Usually you'll have like 2 lines on an avenue and just 1 on like a regular street, and then you've got house connections going to each building from there. So that's that system. I found this is from the New York Times. I just like this image. It's kind of cool. So it's showing the reservoir up here, dropping below sea level. These would be like the chutes going up into the city. And the water distribution system today, it's another little New York Times image. So it's kind of showing, these are all the pipes, they're all underground. So you've got like a hydrant connection here, you've got your house connection going in to give you your shower water, your bathroom water, or whatever you're cooking and cleaning with. Got a fountain over here. The pipes they used to use, we've actually advanced our technology enough to the point where, well, they used to use like cast iron, and they used to use lead joints or lead service lines and stuff like that. Lead obviously is toxic to people, so we don't want to use that. And cast iron gets really brittle over time, so they would break a lot. So we've been putting in these other pipes, ductile iron pipes, so hopefully that'll last a lot longer. That's a lot of what DDC does, though, is water distribution replacement. I mentioned the sewers before, so this is when people stopped taking water from the existing water table, and it started rising again and flooding everyone's basements. So they set up this system of sewers. There's a few different types. I'm sure you've seen this. This is what we consider a catch basin. Right, these are on the sides of the road. It's just a grate that water will flow into. How this works is a road is set up so that there's a crown in the middle of it. So you've got a downward slope on either side going to the curb. That's purposefully done, obviously, because you don't want water pooling in the middle of your street. So they do this, and then it'll go into wherever the lowest point of the road is. It'll go into this catch basin, and then it'll go into an outlet pipe, into a larger system, and then into like a wastewater treatment plant. So that's a storm sewer. We've got sanitary sewers. It's just an example, but anything you're using in your house, what you use to cook with, what you use when you're going to the bathroom, all of that waste goes into a sanitary sewer pipe to a treatment plant. You can look at any of the manholes in the ground. I mean, really go out and look at like all of the different, you'll be able to tell exactly where the water lines are running, where the sewer lines are running. If you go out and you look at the covers of these things, that's kind of interesting. Anyways, the systems here, they originally had all of that water running together. So they had like your rainwater and then your wastewater from your house running through the same pipe. They figured out later that it was actually more convenient and efficient to separate them into separate lines. But the city built them so long ago that we just replace what's already in the ground because there's too much stuff running. I'll show you a picture later. It's so crowded whenever you try to dig into the ground. So we just replace what's existing, so they're combined right now. So the green is all combined sewers, orange are separated sections, and then the gray was, other direct drainage, surface drainage, stuff like that. In the rest of the country, because it was built a lot later, like where I'm from, they're all separated, but they had come up with that technology at that point. So then the sewer water proceeds to the various sewer sheds and to the corresponding wastewater treatment plants. So you can kind of find where you live and what treatment plant is treating your water. I think the Newtown Creek and Greenpoint actually services the most in this area, but they'll take the water in and it'll go through a series of filters and it'll break down the waste and anything, and then they'll get the clean water out again and be able to release that into the oceans, into the streams, and stuff like that. It's kind of how the sewer system works. Waste reduction and sanitation. So we know about this because if you go out in the summer, it smells awful, right? All the garbage is on the curb. The original systems, I think it was much worse from what I hear in the past. So people would like throw garbage out their windows onto the street. They dump it in the harbor, stuff like that. I actually found that they had this system of trash-eating pigs. So there's like a bunch of pigs that would run around the city and just eat this. They didn't have as many plastics and stuff, that we do now. So they would eat all of that, and then eventually they decided it was unsanitary, and they got the pigs out of the city. They hired a bunch of people. They called the White Wings. They were all dressed in white because they wanted to emphasize cleanliness and sanitation. And so they were kind of the street sweepers. They were getting all the trash out of the streets. That was the first comprehensive sanitation system that they had in the city. So the current system, we're still kind of doing that with just picking up trash off the curb. The issue is that we don't have anywhere to put any of this because you can't, there's no alleyways built into the city. I always think about like how Chicago, they had the Great Fire of Chicago. I feel like they got a second chance to redesign their city. It's not a good thing, but they were able to put in the alleyways and develop a better trash system. So New York never got that chance. So I think whoever figures out how to deal with this will be a very rich person. But the Roosevelt Island trash system, which was built a lot more recently, is actually kind of a trash conveyor belt. So in all the buildings, people can put their trash into this chute, and then it'll go down and onto this conveyor belt and be whisked out underneath the island. So I thought that was kind of cool. Transportation transportation growth, so how the city grew in terms of the options for transportation that they had. Because early on, obviously, it was just like walking or riding animals or being pulled in a cart by an animal. So in the Commissioner's Plan of 1811, they had this idea for this huge grid, which New York is pretty much known for today, but they were having issues with people trying to claim land plots. People were fighting over, what the price is, what the size of it's going to be. They didn't have any way to regulate how people were buying plots of land and to make sure that the streets were running in straight lines and stuff like that. So they decided to set up this whole system of avenues and streets all the way up the island, which is kind of a bold idea because they only had 100,000 people living there at the time. So to anticipate that you're going to undergo construction and have who knows how many people living here that will fill up the rest of this island in the future was a pretty bold idea, but I guess that kind of facilitated how the city has grown from that point on. So they set up this grid, and that's really, they also acknowledged, this is Broadway, which this was the original Indian Trail going all the way up the island of Manhattan. So that's why it's diagonal, running through the middle of the city. And then, of course, Central Park is in here, so there were some different changes that had to be made eventually that they added in. But this was kind of the original design. I think they actually thought about doing, in Washington, D.C., they have those giant circles. They thought about doing that at one point. Someone was very adamant, though, that wasn't the way to design the city, because you have to design with curved buildings then, you have to design around the circles. It's a lot easier to build just a rectangular building in every way, and it was just more effective to set up the city like this. So they were able to then, put all of the subways along the street lines. They could run all of the utilities along those same lines, and then into each building as it was built up and on each block of the city. So the early transportation options then they had these elevated railways called Ls. They had horse-drawn carriages, they had trolley cars. A lot of the time when we're digging, we still find trolley tracks in the ground. So these were the original, some of the options they had early on. Then as the population grew more and more, they needed a larger system that could handle the volume of people that wanted to travel on it. So they decided to build the subway. And they also didn't have anywhere to go other than below ground because they already had above ground systems and stuff on the streets. So they decided to build on the ground. They used the cut and cover method, which is basically where you dig a hole in the street, like a trench, and you solidify the sides, and then you put a support above so that people can drive or whatever, walk on top of this that'll support that. It's kind of what that looks like. And then you can work below there. So it also confines them to building in the street grid itself, because you can't do the cut and cover method when you have a building there. I mean, they could have done a deep boring method, but they didn't have the technology at that point. That's how they built the Second Avenue subway, where they just had this giant boring machine, and it was really, really deep in the ground. But at that point, it's you don't have any other room. There's utilities, there's other things over there. So that's why they did it that way for the Second Avenue. But when they were first doing it, they didn't have the technology there. They also built the underwater tunnels, so they would dig down until they got to the the muddy, silty material just below the river, and then they would kind of dig into that, and then they would lay all the bricks around it to support that. And then to keep the water out, they pump in pressurized air. What they found out, though, is people would come down with something called the bends, which is diver's sickness, because when you have this pressurized air inside of you and then you go up to the surface too quickly, you have all these air bubbles in you. It's it creates an imbalance and people get really sick from it. They didn't know this at the time, so this is how they were building everything. So, and they would also go and dig all the way down to the bedrock way below the bottom of the river, and then they would dig and try to reach each other in the middle, which is kind of a gamble, because how do you know if you're going to you have to be very, very accurate with this. So I always think that's kind of an interesting, and people have made mistakes at this before, they've missed, that's difficult to correct. So that they were able to do that at that point is kind of a big deal, I think. They also had some decorative subways, like this is the City Hall subway, which I guess you can, I haven't been there yet, I'm trying to figure out how to go there. I guess you have to ride to the end of one of the subways and then, I don't know exactly, but they put a lot of artwork into this in the old days, which I thought was cool. Another thing you can look at is, I'm sure you've seen these like little round glass pieces in Lower Manhattan, right? So these are actually little lights for people to work under. So underneath all of those, you've got building vaults, and people used to work down there. I don't know if they still do. I'm thinking not, but that's how some of this was set up. And then like this, I was working at Astor Place. These are, if you look at the material that you have, you can see like granite slabs and stuff like that. These are all building vaults or subway vaults, stuff like that. We weren't allowed to dig that up because if we pull that off, that's literally the roof of this underground vault area. So we have to build around that because it's a historic area. But anyways, sometimes they would build a station so high up that the top of it was the sidewalk, and that makes it difficult now to replace. So something practical. And you've got like your bridges, of course, which really revolutionized how people were able to. It revolutionized like the social culture in the city too, because if you think about it, people are living in Brooklyn. It's hard to get over to Manhattan at in a quick way. So building a bridge allowed people to kind of live in an outer borough and then travel over to work in Manhattan and then come back. So I thought that was kind of interesting how this really connected all the boroughs and created the city system as it is today. They built this, the foundation parts of it, with these things called caissons, which are basically like if you took a box and it's hollow and you took out the bottom part of it and you force it into the ground, and you create a shaft in there where you can pump the water out below it and then dig out, and people are allowed to work down there. That's what that is. And they would also pump in pressurized air into this, so people would get the bends from building this. So that's the Brooklyn Bridge. They built most of them this way at that point. Then you've got your power sources and your utilities. So we've got, just gonna go through this quickly. You've got like your steam power, which is an old, you just heat up water and the steam will rise, and you can use that for heating and cooling systems. It regulates room humidity. It's used for disinfectants. If you've ever seen these steam towers here, that just, if you have excess steam, it allows it to release in a safe way. And you've got gas used for heating, cooking, heating, electricity generation. You've got electricity, lights, chargers for devices, small appliances, and then your telephone and internet. Of course, steam and gas run through large pipes underground. Electricity and telephone, when that was first, they used to put up these huge poles. So you can imagine what the city would look like if they had left this here. Like, I'm sure it would have just gotten worse. So we're lucky that they decided to put them all below ground at a certain point. In a lot of the outer boroughs, they aren't all below ground, but they had decided in Manhattan to do that. So now you get this, basically. So you dig up the road and it all looks like spaghetti. It's got like, everything's intercrossing. You never know what you're gonna find when you dig down there. Because like, a lot of the records have been lost over the years. So you never quite know what you'll find. This is one of my pictures from one of the sites we were working on. And then just quickly on like the evolution of skyscrapers in the city. So the skyscraper didn't really come around until the elevator was invented. Because if you think about it, the richest tenant of a building, like no one wants to walk up 10 flights of stairs to get to an office, right? So the richest tenants would always want the ground floor suite because people would go there. They wouldn't go up all these steps. Once the elevator was invented, though, everyone wanted the penthouse suite because the views and everything, you were able to get up and down fairly easily. So that really changed the skyline of Manhattan. I'm going to go into kind of what I do on a daily basis now. So I do infrastructure construction. This is one of the pictures from our site. I think we were laying water main valve. That's me. It's an inspector. I don't wear this on a regular basis. So what I do on a regular basis is kind of everything roadway and below. So we do sidewalks, curbs, pedestrian ramps. We do roadway restoration. We replace water main pipe, sewer pipe. We work around utilities, like I mentioned before, like steam and electricity, all those lines that are intercrossing there. We deal with that. Everyone will ask me, can you fix the subway? And I say, well, you know, because they figure, oh, you work next to it, you must be able to, kind of in a joking way. And I'm like, no, they're very protective over their stations. They don't let you touch it at all. If you scratch one of them, they're like, replace it, you know. So we're really careful around that. Well, we do all of this stuff. We'll do plaza features. I worked at Astor Place, so this is now my NYU. I don't know if you've been over here, but I came on kind of at the end of it, but we put the cube back. I was there for that, so we get to work with public art. We do like specialty, like sidewalk work. In historic areas, it's tinted like a darker color, and then you might have like an exposed aggregate with it. I bet you didn't know that concrete could be fancy, but it can. So we've got that. We work with landscape architects to create like bench systems. These are granite benches or steps. We've got planting areas. We do all these different features, so it's kind of interesting because you really get to create the landscape and what people will be using on a daily basis. You get to work with all types of people. So this is us in front of the cube. We work with the other city departments, the Department of Environmental Protection, the DOT, Department of Transportation, the Parks Department. We work with the construction workers, we work with architects, we work with landscape architects. Sometimes we work with archaeologists, because if we're digging down in the historic areas, we might find something, because again, people would throw their trash into the ground. So you never know what you're going to find down there. We work with community boards, we work with the mayor's office, all different types of people. So it's pretty interesting. This is some of the stuff we found. So this is an old pipe from like the 1860s, I think. So this hadn't been touched in probably 150 years. That sand wasn't in there when we took it out. I don't know where that came from. This is all like iron deposits. So that's what we're taking out of the ground. So when everyone gets mad that we're replacing their water main, I say, oh, this is what you were drinking out of before. So we're putting a new one in. Found this old shovel from, I think, the 1850s. So it's got this wooden handle. So that was kind of cool, pretty intact. And I actually know that the person that was running this project, this is near the Astor Place one, but they found these old burial vaults near Washington Square Park because it used to be like a potter's field. So they found all these bodies in it, and they had to call the archaeologists over and stop the project for a while. It was kind of an interesting time. So our old commissioner said once, as we build the future of New York, we rediscover the past. So I like that statement. So kind of as we're digging up, we really get to understand how things were done in the past and how that relates to what we're doing today. And I'm going to show this video here in a second. I don't know how to start this. This is from DEC.
My name is Audrey.
My name is Abdiel.
Zia.
Valerie.
Victoria.
Ashwani.
Helena.
Clifton.
Gabriel.
Donna.
Noah.
My name is Barbara. Blake.
Safi.
Dalila.
Hi, and I'm Charlie K.
I live in Manhattan.
I live in Harlem, New York.
Woodside, Queens.
About two miles from us.
In the Bronx. I live in Brooklyn.
I live in Staten Island, and I take the ferry every day.
I am building for the people of New York City.
I am building for a more efficient and effective New York City.
I am building for the future infrastructure of New York City.
I'm building to ensure that clean water continues to be delivered to all New Yorkers.
I'm building for the safety of New Yorkers.
I'm building for libraries. I'm building for literacy.
This is a haven for them. They can actually sit in a safe environment and work and learn.
For a city that takes care of its people to improve their quality of life.
We work to improve public health through the design of our buildings.
I am building for a better urban environment.
I'm building to preserve, educate, and inspire.
One thing? There isn't one thing.
All the employees here are professional and dedicated to their work.
I'm building for making the city more beautiful.
I'm building for quality and longevity. We get to try new technologies which will improve the life and the quality of our projects.
I'm building a greener city to preserve our resources for the next generation.
Providing a building that meets the needs of the occupants at equitable cost to the taxpayers.
For a system of preventative maintenance
I'm building for the future of all New Yorkers.
I'm building to ensure communities are more well-informed.
I'm building for the prosperity of small businesses in the city.
I'm building for equality, and I'm building for inclusion.
I'm building for a city that makes people love their city and makes their city love them.
I'm building for the greatest city in the world.
Hi. Okay. So, thanks everybody for coming. Now is the time where you get to ask whatever question that is, relevant to your lives regarding the talk that you just heard. As with, for anybody who's new, any question, anybody who asks a question also receives some piece of swag. So today we have hats. So let's start off with the question. So we have someone over here, and we're gonna ask you to ask your question fully. Wait for the microphone before you ask your question. And for anybody who's not used to using a microphone, it's like you almost have to eat the microphone, okay? Just so we can make sure that we hear your question for everybody. Okay, so let's start off over here. Sorry, excuse me.
So what made you motivated for you to do your job? What was some of your motivation?
So I was always interested in math and science, I guess, growing up. I was good at that. I thought that was interesting. I didn't know that it was engineering that I wanted to do. I think I looked at meteorology at one point. It was very different. But I was looking into engineering at a certain point because I like math and science, and it's a good career to go into, a lot of opportunities. And then I was kind of deciding between the different types, and I was looking at mechanical or civil, and I just liked the idea of, I didn't want to deal with all the moving parts all the time, but I liked the idea of buildings. It's very visual, it's very relatable to people. I mean, we live and work in them all the time, so it was something that I could see that was tangible, and I liked the idea of designing for that. And I don't know, you can have a big impact on your environment with civil engineering. I get to work with everyone in the city. I'm creating stuff that's going to be here for hundreds of years now, so I like to be a part of that. So I think that was why I wanted to go into civil engineering, but city civil engineering in particular.
I'll take this question down here.
What's the favorite part of your job?
My favorite part of my job. I like that I get to be outside a lot. I'm kind of half in an office, half outside. So I can go to the site and be out there. I get to go to new sites every day. We have a multi-site project right now, so I'm up in Inwood at one point, and then I go all the way to Brooklyn in the same day. And then I don't know, I guess the travel and the experience I get and all the people that I meet is probably my favorite part of that.
All right, let's go back here over. Pardon me. There you go.
So is there less underground stuff as you get further uptown since it's newer?
I would say yes, in a way, a little bit less than, I don't even know about that, because we were just up in Inwood, and there's a whole lot of stuff still down. I guess there's less older things, there might be less abandoned utilities. It's probably all active at this point, so sometimes in the, down there we'll find old conduits that we don't know if they're active or not. So I think there's less of that, but there's still plenty of utilities. The population stays, it's pretty crowded everywhere on the island of Manhattan. So yeah, less old artifacts, I would say, though. Yeah.
You want to field?
We'll take this one here in the center.
Hello. My question is, where do you see civil engineering going in the next 10 years, or with new technological advancements?
New technological advancements. I think it's all going to be kind of the green energy movement. So it's integrating that technology into buildings. They're using things that like curtain walls and different other technology where you're reducing heating and cooling costs and stuff like that. In terms of like, I don't really know if you can reinvent the wheel on concrete because it's been there forever. You know, there's pretty much, we've done everything we can with that. So I think it would be finding ways to, I don't know, figure out how to use materials in new ways. Maybe smart roads, maybe, you know, stuff where you're using different plastics and things that are a little more durable than just like asphalt and stuff like that. It's kind of where I see it going in terms of infrastructure, yeah.
We have a couple of hands up over here.
So we have so many cities in the United States. What made you choose New York City?
You know, I think if you grew up if you're not from here, it's, you know, we see it in the media and everything. It's like, if you're from like the Midwest or something, it's in everything. So I think it's just the largest city you can go to in terms of doing city infrastructure work. So I kind of I like the city in general, like all the people and the hustle and bustle and all of that. But I also like the chance to work in a very challenging environment, because if you're working in like Minnesota, we don't have all these utilities in the ground, so it's not going to be it'll be easier, but I like the challenge of working in New York and the history of, you know, being able to dig and find all of this old stuff, because it's got like the oldest infrastructure in the U.S. So I think that was the reason why I chose here, was the opportunity for experience, yeah, with that.
All right, one question up here. So you were mentioning Chicago fire and Sandy. Do you think there is any catastrophe which can destroy the city or do a big damage?
I mean, I guess another, like, I don't think the fires would do it now, because I think we have a comprehensive system to fight that, but maybe another really bad hurricane. You know, we're not going to get earthquakes over here, we're not going to get tornadoes or anything, so maybe another worse hurricane, that would cause more damage than anything, in my opinion, but I don't know when that's going to come. They're trying to set up systems right now, like with the South Street Seaport in that area, to like make it hillier, so you have like more barriers before you get into the city itself, so that it'll stop the flow of like this storm surge. So they're implementing stuff to hopefully protect this, but I don't think anything will necessarily destroy it, like a natural disaster would, you know.
We're gonna go over here.
Maybe a blackout. Maybe not.
What are some misconceptions about your job?
Let me think. You know, my old college roommate asked me, or I told her I have a city car, and she thought that, you know, and then I mentioned it was a Prius, and she thought I was in like a big pickup truck or something. So there's misconceptions about, like, you know, if you're doing city engineering versus other types, and I think just also the amount of engineering that I am doing personally is, I'm not on the design side of it, so people might think that I design like the roads or whatever, but there are other people that design this, and I get it like 3 years later, and then we're just supposed to implement that, so the separation there. So I'm doing less of the actual, you know, the civil engineering design. I could get into that eventually if I wanted to. But I kind of like being out in the world and implementing it in that way. So I think those are some of the misconceptions.
We have a question here.
Hello.
Hi.
So I'm in physics right now, and we're learning about like energy sources, and we all should know that like biofuels are a non-renewable energy source. And while doing some research, I was looking at like roads that would like made out of solar panels, and like would or like roads where when the cars drive, when they would take energy from the car and it would eventually be used to power the whole city. Do you think that's like a realistic goal that New York City can achieve?
I think eventually it could. It would just take a long time. And there's some practical applications of that, like, you know, the weather, and how do you weatherproof that? You know, sometimes they try to implement stuff and it doesn't quite go the way that you think it will. I think it's going to take a long time before they get to that point, basically. Yeah.
All right. You guys have so many questions. Okay.
Okay, so
remember how you talked about they were building trains underground? Like, how are there still trains that are outside today? Like, how does that work? Yeah, like some of the trains in like the Bronx, Queens, and Brooklyn still go outside.
Yeah, I don't know the reason why they decided to build those above ground. It could be like the material they were built. Maybe the bedrock there was like really high. They didn't want to tunnel through that. I'm not sure. I'm sure maybe they could. It's probably a money issue, honestly, like the funding for that. The MTA doesn't have money to like fix the issues that they do have. Why would they put one underground, when they don't necessarily have to? So I think that's probably the reason why they're out there.
And I have another one. Who is currently working on the trains? Because like maybe they could help like to reduce signal problems and things like that. Because sometimes the trains can be delayed. Like, oh, darn it, I need to get to school.
The MTA is a city. The MTA is not the city.
I have some mistakes, but you want to call that.
I think you have a couple of disgruntled strap hangers here.
Yeah.
The MTA is a state agency.
Yeah. Governor Cuomo, who's the governor? Cuomo, yes. Thank you, sorry, I had a brain fart.
Yeah, because the signal issues are something that could be fixed easily,
We did a water test in our school, and I know you mentioned the UV treatment of the water. We found like really low chlorine levels according to our at-home testing kits. I mean, they were at-home tests, but does New York City have lower chlorine levels because we use the UV treatment, or should we still have the same chlorine, like minimum chlorine levels?
I think it's actually, lower for sure. That's one of the things, that's why they implemented that in the first place. So I don't know if there's other places that have like more filtration, because if we had done like a wastewater treatment plant, maybe we could have gotten more layers of filter, but that costs a lot more money than what the UV light does. So I think that we do have lower levels. I mean, I've been to other parts of the country and tasted the water, and it's not great. So this is really good water. Yeah.
I agree with that. I hate brushing my teeth on vacation. Okay.
We have a question here in the middle.
Yeah.
So this kind of goes back to the question that somebody else asked kind of about why did you choose New York City, and I kind of wanted to like forward that and say like why didn't you want like a challenge of bringing something new into like a smaller location that's not as modern as New York City?
Good question. I think it's just learning. Well, I don't know what the new stuff is yet. Like I'm still, I've been working for like several years now. So I think I could eventually do that. That's one of the goals, is to bring it to newer areas. But I have to come here first to get the experience, and then maybe I'll take that elsewhere. We have a lot of new technology, but a lot of the stuff is older. So like there are areas of the country that do have newer technology than we do, just because they've implemented it more recently. So I don't know. I could still implement new things in this area, I would say.
All right, we have a couple over here. I'm out of swag though, sorry.
How long does it take to become a civil engineer?
So I'm kind of still in the process of that, because you have to officially call yourself an engineer, you have to get a professional engineer's license, at least within civil engineering. I graduated and then I moved like a month later, and then I had a job already when I came here. And then within like 6 months, they made me a resident engineer, which is fairly fast. But I was glad that I got the opportunity. But you have to work for 4 years before you can get your professional engineer's license. And then that really opens doors, and you can design stuff, you can sign your name to it and stuff like that. So it wasn't that long to get this job, I would say, but in terms of calling myself an actual engineer, it's going to be like in a year, maybe. So, yeah.
Just to follow up on that, what was your major in college?
Civil engineering.
So it was.
Yep.
All right. Okay, we'll have a question over here. Sorry. Did you ask a question? No, it's okay.
Hi, how do you know how to connect the pipes?
How, physically connect them?
I guess. I don't understand how the piping systems work.
Oh, okay. So there is you have like your standard pipe, and one end is kind of like a bell shape, and one end is, they call it the spigot, but it's straight. And then you have like this little, they put in like a rubber, like, I don't even call it a seal. And then they've got these little metal things in it. They call it the teeth. So it's kind of like when you have a Chinese like finger thing, you know, where when you pull it apart, it just increases in strength. So it has this seal system, so you push it in, and then you can't pull it apart because the things within the seal will dig into the metal. So that's how. So they just push one into the other. It's really not like that much more complicated than that. Push one into the other, and then keep doing that. So that when there's stresses trying to pull it apart, it tightens up basically, like the Chinese finger thing. Yeah, it's kind of how that works.
I'll take this one right in front of me.
Do you think there are any like downsides to being a civil engineer? Like, what's your least favorite thing about being a civil engineer?
Least favorite. It can be a little intense, especially if you work in construction. Like the culture of that is very like rough, I would say. So maybe the fighting with that, and contractors are always trying to fight you for more money, and you have to kind of watch them so they don't try to, you know, cut corners with stuff and like not give you the best product. Not all of them do that, but a lot of them do, because they're trying to make money out of this. So it's like a business thing. So I think trying to, like, always being on edge, trying to make sure that, and then people fighting about it, and me trying to, you know, make sure that the best quality work is still done despite that. So it's probably that stuff, yeah.
Any more questions?
What were some of the motivators that helped you become an engineer?
Motivators, well, again, I was kind of, I think at home, my dad is kind of an engineering type, so they promoted, when I was interested in science and math and stuff like that, he really promoted like, oh, of course you should be an engineer, because that's a practical application of that. So I think that was when I first heard about it. And then it was just, the farther I got into it in school, the more interesting I found it. I mean, I think concrete is like very interesting, and I think if you find that interesting, it must be a sign.
So concrete motivated you?
It did.
Yeah, that's awesome.
I mean, I could talk at length, but I don't.
Maybe outside of this, I'll chat with you about concrete. We have a question over here. Hold on.
Okay, I'm an adult, not a student, so sorry, apologize for this. But speaking of concrete, this week in South by Southwest, they introduced the idea of 3D printing a home. They took $600 worth of materials and they 3D printed this new kind of concrete. Yeah, it's super interesting. Do you see applications for 3D printing for civil structures?
Oh yeah,
going forward? I mean, are you doing anything now?
We are.
Tell me more.
I mean, I'm not personally. I also volunteer with another program where we do this mentorship for high school students through DDC. It's called ACE, Architecture, Construction, Engineering, and we're looking into like a flexible home type. But we've been studying modular homes, and this technology is all there. It's just it's not implemented on a large scale level yet. So, but you can. I see that definitely becoming something that, because I know people that are looking into 3D print, like modular homes in a real sense right now. So this is something that I think will definitely be, because you could reduce like labor costs and the time it takes, you know, you can produce stuff off site and bring it over there. Yeah, I definitely think this is something that'll increase.
We have a question.
Hi, Maddie.
Hi.
So my question for you is, being a woman in the engineering field, could you give some advice for the young ladies in the audience about your experiences and maybe some tips on like how you got to your level of success?
Yeah. I would think of, I'd say like, I don't know, I don't think of myself as like a woman engineer. I think of myself like an engineer who is a woman.
Heck yeah.
Right? So it's not like I'm different or doing anything differently than what any of the guys are doing. I actually like all the guys that I work with, and then there are other women that I work with too. But I think it's just like, you know, you can deal with the older guys that have only worked in a certain way and stuff like that. And you just have to hold your own with that. and not fight back against it and not get really, it's easy to get really angry about it, but I really try to hold my emotions in with stuff like that on a day-to-day basis. And I think if anything, there's more opportunities for women because they're really trying to promote other, the diversity thing and all that. So if anything, I've only been helped by that. I don't think I've been held back at all. So I think if you have the motivation to do it and you can handle that and you know what you're doing, obviously, if you want to go into it and you've studied and everything, you're fully capable to do anything that, is out of the box, I guess.
Okay, and there's one more over here. Yeah.
Hi, Maddie. Matt, question for you. Speaking from experience, studying civil is hard, and it can really challenge you. Did you ever go through a point in time in school that you really had to sit and reevaluate your decision of studying civil? Because I think everyone pushes women into STEM or students into STEM, and they never really talk about the struggle behind it, as it's not a reality that students go through. So can you talk about it and what you did to get through it?
Yeah. There was maybe many moments, but especially later in college when it's when you're really tired of studying all the time and you're just ready to be done, you're kind of burnt out, and it's getting really difficult. That I was like, do I want to do this? I don't know. And I think you have to. You can. I guess at that point I was almost done with my degree, so I wasn't gonna not get it. But once I got through the difficult portion of that, I got my degree, and then I got out here, and I was like, oh, this is what I want to do. So I think you have to kind of get through. Sometimes it's overwhelmingly difficult if it's making your life you have no interest in it whatsoever. Maybe you should look towards a different path. But I think I always knew that I was still interested in it, and I didn't feel like I was pushed into it just because. I went into it because I was interested in this. So I think it's discerning kind of whether you feel like you're being pushed into this for different reasons, or if you went into it willingly, you're interested in it, and you're just having a tough time with the material. Because once you get out, college is really probably the most difficult part of all. It's rigorous with the math and everything, and very difficult. And then when you get out into working world, it's different challenges, I'd say, not the same type of intensity of math and science. So I still apply a lot of the concepts that I do to my job now, but not the same ones, I guess. Yeah.
Can I round it out with a question of my own before we end?
Yeah.
So RockEDU, we work a lot on microbes and microbial communities and things like that. And I know a lot of people are studying how microbes are kind of creating their own little niche environments in the built environment. And so I was just wondering if you've ever come across, or if you or people in your field are considering microbial types of biofilms or building materials of that nature to integrate into the buildings as we sort of start thinking about these smart buildings.
I haven't heard of that being implemented, but that would be cool.
Yeah, because these microbes are everywhere anyway, and you can manipulate them to create energy and all these other things. People are working on those concepts at least.
Right.
There's nothing commercially available. And so I don't know, I just was wondering about the intersection of this microbial community and the built environment. I don't know, or layer.
Maybe we put in bioswales where we try to get all of the bad materials that come on the street before they go into the sewer system. Maybe something like that.
Sure.
When you're out in the environment there itself. That'd be interesting.
Yeah, and just out of curiosity. Yeah. Oh, we do have another question. Well, all right, one more question and then we'll get to the networking. Hold on.
Hi, in your opinion, have you seen a decrease or increase in the number of jobs in the field of civil engineering because of the development of technology?
Definitely an increase. I guess the infrastructure is I will never run out of work to do, basically, because the infrastructure is breaking down, it's really old, so it's we're gonna have to keep, I don't know if it's technology, I guess it is technology, but we just have to replace the old systems so that they don't break. By the time those get old, we'll have to replace them again. So, and, you know, I think it's a continuous cycle. Like, you'll never run out of work for civil engineering. That's why it's a good field to go into if you're interested, because you'll always be able to find a job. And yeah, so it's been increasing.
Great. So let's give Maddie a round of